Alrighty, here's a quick video on feedback nodes. So we're very familiar with this point with loops. So for example, if I were to drop down a for loop, I can right-click on the right or left side and add a shift register. And let's just create something that counts. So I'm going to go into the numeric palette. I'm going to drop down the increment because we'll increment by 1. And I can create a control called number of counts, and then I can create an indicator called end of counts. If I come over here and run it, well, nothing happens because my number of counts is 0, so I'll put something in here. We'll call this 1,000 and say my number of counts is 1,000. And if I run multiple times, it keeps counting up. That's because I forgot to initialize my shift register, so I'll come in here, right-click, create a constant, and we'll start at the number 5. And so from here on out, every time I click run, I'll get 1,005. So that should be all pretty basic at this point. So just by way of example, I'm going to put another for loop down that's right next to this one, and I will hold down control and drag the plus down to get an additional copy. And normally, in fact, actually, let me do this outside the loop as well. If I create an increment outside of a loop and wire it to itself, no, actually, I do get a feedback node. So this node appears here. Seemingly, this should give us an error, right? Sending an output back to an input, it doesn't really mean anything. However, in the context of a loop, it actually could mean something. And so this icon that appears here is called a feedback node. And we can explore a little bit about what that might be doing. Create an indicator here, and similarly I could wire my indicator out. Here auto indexing is enabled, so if I create an indicator I'll get an array, but I don't want an array, so I'll say right click disable indexing. When in doubt, right click on stuff, and then again right click create indicator, and now I have end of feedback. Oops. So here's my 2 indicators over here, and if we run this guy, well, sure enough, we get 1,000, 2,000. So this is behaving just like a shift register, and in fact, that's what this is. So what a feedback node is doing is it is taking the output of one loop and sending it out to the next loop. So just like a shift register does. The feedback loop can be confusing, however, because it's violating the data flow, right? Data is sort of flowing into this thing and back out rather than out the loop. So 2 different ways to accomplish the same thing. Feedback nodes and shift registers can be used for other things, of course, but in this case, they're nominally the same. Well, how do I get this guy to initialize? Well, sure enough, there's an initialization terminal here. Again, I can do Control-H to pull up my context help and learn a little bit more about that. Detailed help will help me even further. I get rid of that because I don't have a lot of screen space here. And again, I can right-click and do Create Constant. If I put the number 5 in there, well, I don't really need my x plus 1 anymore. Then and now I will see the same behavior. So for this case here, these 2 are nominally equivalent. So shift registers, feedback nodes operating in the same way. For the time being, I would suggest that everyone use shift registers because it allows you to see the data flow. If you were to create a case statement around this, you would have empty tunnels. Filling in those tunnels would give more valid values. It's going to be more consistent with the data flow architecture that's inherent in Labview. This is a nice shortcut, and in some cases it can be very helpful. However, for beginners, I think a feedback node can be very, very confusing. There's also an option to remove Labview's ability to drop feedback nodes down automatically from within tools and options. We can go turn that off. Let's see, finally, if I wanted to hand this in for homework, I could do edit, make current values default, and then when I saved this and reopened it, the 1,000 will stay in here, and then file save or file save for previous versions if you're using a more current version than what we're using for the class. That is a quick tutorial on feedback nodes within loops, and I hope that helps.